Hello students, today I am going to discuss uh, two types of searching techniques that are very essential in our coding round that are generally asked. First of all, what was the necessity of the two kinds of searching techniques? And more importantly, what is searching? Why do we need searching? So searching is a concept where you are given a set of integer array or string array, whatever, and with along with a key element which you need to search throughout the array. For example, let me consider, say this is an array and it is having elements with 15, 16, 20, 25, 30, 35, 40, etc. And say you are given a target of say 25, and so here is the index at index 0 1 2 3. At index 3 lies 25. So in the output you need to return the index, that is index is equal to index, I mean, or you can just return 3, the index value. So it is 0 1 2 3. At index 3 lies 25. And now consider, take for example, if the target would have been say 50. So 50 does not exist in this array. In that case, you need to return -1. Yes. So where target is equal to 50 and 50 doesn't exist in your array of integers, and therefore you are we need to return -1. Okay. So looking at this problem, what comes first to our mind is like searching for the element, comparing with each element one by one. Say suppose I am comparing 25 with 15. So 25 is not equal to 15, therefore we move to the next index. 16 not equal to 25, move to the next index. 20 not equal to 25, move to the next index. And 25, that is same as 25. So here you break the loop and return the index of the particular element. Okay, now this process of searching where we compare each element of the array, as we are linearly moving from the first index to the last index, the, and therefore we are linearly moving, and hence it is termed as a linear search. So in linear search what we do is exactly, say suppose this is the array. So first we need to consider index 0. Okay, let me do a dry run for you. So say suppose this is my array. I am just copying it here. Error is equal to what did I take? 15, 16. Okay, yes, 15, 16, 20, 25, 30, 35, 40. So suppose I am using a pointer, say suppose I. Okay, so first I points at the at index 0. So and target, there is a value called target. Target is equal to, let's suppose 25. 25. Okay. Now in this case, so 15, that is ARR of I, ARR of I, presently I is equal to 0, and ARR of I is equal to 15. So 15 equal to 25, and that statement is false. This is definitely false. So I becomes 1. Let us move I to the next index. So let's say here moves I. Okay, I is moving here. I moves here. Okay. And so here again I is equal to 1. Error of I is equal to 16, and 16 is equal to 25. It is false. Okay. Similarly, 20, I when I is equal to 2, error of I is equal to 20, and 20 equal to 25, that is also false. I is equal to 3, error of I is equal to 25, and 25, let me draw it from here again for you. Say when I was here. Okay. uh, ARR of U was equal to 20 when I was pointing at index 2. Okay, let me write the indexes for you. When I was here, I was pointing at index 2, and ARR of I equal to 20, and 20 equal to 25, that is false. In the same way, when I becomes 3, when I becomes 3, I is pointing at 25, and 25 equal to 25. Okay, so that is our true statement, and here we stop our execution as the target is found at I is equal to 3. So this is our index that we need to return. Okay, so in the code, if I write, I am writing the pseudo code for you. Okay, say void, some void if void linear cert, it accepts two arguments, that is say int ARR and the target value that we are supposed to give. Okay, so let us take a loop that should iterate over this array. Int I is equal to 0, I less than, okay, so the length of the array should be considered. Say n is equal to int n is equal to a size of ARR dot size. See, this is int n is equal to ARR dot, as it is a pseudocode I am writing. So that is why I'm writing ARR dot size. It will vary as per the programming languages you are using. Say suppose in case of Python we will be using the len function. In case of C we use the size of ARR by size of a particular element, and that changes as per the programming languages in which you are writing. It is just a pseudo code, so this may vary. Uh, as per the programming languages you are using. Okay, you may change it as per your convenient programming language. So I is 0 at first, then I is less than n. I becomes at each step. I will be updating with I plus 1 pending brace, and if array of I equal to target. So I'm checking if at any moment when I reaches to the index, to that particular index which consists of the target value, it should return. Okay, let me change it to int so that it should return that particular index. Okay, otherwise it should return -1. So how will this loop work? Basically, when I is 0 and at first error of 0 is being checked with 25, and error of 0 was 15. So 15 equal to 25, that condition is false. So this if statement will not get executed. So we do I is equal to I, we update the I to the next value. So I becomes I plus 1 and I points to the next index, that is I equal to 1, and error of 1 is equal to 16. 16 equal to 25, that is also false. So moves to the next index, that is your index 2, and then when I becomes 2, error of 2, that is 20. 20 equal to the target 25, so that becomes false. And so again that iteration goes to the next statement, I is equal to 3, and when I becomes 3, 3 error of 3 equal to 25, and the if condition becomes true, so we return the index. So this syntax was very easy. It was just like we do manual comparison, that whether we check with each element. Even when we do manually also, we actually check with each element in a list, that whether we are getting, just consider it like a merit list that when comes out in your college. So while checking your result, okay, so you check from the topmost portion up to where you find your roll number. Say your, in case of competitive exams or other things, your roll number may go up to 250 or something greater than that. Okay, or in your school result even, sometimes you have a bigger roll number. So you search it from the topmost section, and then you search for your roll number and get your marks, right? But uh, if we consider this code of linear search, even for the computer, isn't the is it not that the steps are becoming too large? Like, for if the value of n is very large, say around 2 lakh to 2 crores, or 2 into 10 to the power 9, something like that, it will take a longer time to execute, right? And that is obviously not the thing that we want, because uh, nowadays we provide such algorithms that are beneficial, that gives the result as output in a faster manner to the users, right? So we need a more optimized approach, so that this code runs faster. If we consider this code, it takes about n iterations, n steps, because this loop will be executed at the worst case, say when your target is equal to 50. So 50 is nowhere in this array, right? So it will do up to, the loop will run up to n, that is the length of the array, right? and it will find the element nowhere, but the loop runs for n steps. At the worst case is when you find no element in the array in linear search, and in such a case it takes n steps. And say if n is very large, say if n is very large, very large, then just imagine how much time this algorithm will take to give you the resulting output, right? And of course, we can understand from our examples, the users are very impatient and they want the output, the result very fast nowadays, right? That is why we are emerging, the technologies are emerging. Otherwise, what is the benefit of using a computer? Okay, they could have searched it manually also, right? So therefore, we have a more optimized approach to the searching technique, and that is called binary search, which I will be discussing in my next video. Thank you.